Hello and welcome to this session of answering or looking at past CXC multiple choice questions. In this segment, we'll be looking at geometry and trigonometry and dual algebra. Do enjoy. This question reads, the image of a point P12 under a translation is P prime minus 5 minus 4. What is the translation vector? We have this question to tell us that P, which is 1, 2, undergoes some translation txy and they arrive at p prime, which is minus 5 minus 4. We're looking for this translation vector here. What did it underwent? Now the translation txy in transposition, taking the starting point over the equal sign, it would have been p prime, subtracting the values of p, which is our starting point. Hence, our translation vector would have been txy, which gives us minus 5, minus 1, minus 4, minus 2. In simplifying our translation vector, txy would have been minus 6, minus 6. So our solution for this question is A. The item referred to the following diagram now drawn to scale, which shows a sector of a circle with the center O. Now, when we look at the diagram, we have a sector and the sector angle is being represented by 60 degrees for the sector OPQ. So if the length of the minor arc PQ is 8 cm, what is the circumference of the circle? Now here we are told that PQ, the length PQ, which is 60 degrees, gives us a length of 8 cm. Now this 60 degrees is a fraction of the circle, which is 360 degrees. So how many 60 degrees is in 360? If we take 360 and divide it by 60, we would have seen we have 6 60 degrees gives us a total of 360 degrees. Now if one 60 degree sector is 8 cm, we could say that 6 60 degrees would have been 8 cm times 6, which gives us the total length of the circumference, which would have been 48 centimeters. So our solution for this question is C. The gradient of AB in the graph above is, here we have a graph showing us a line segment of AB, and A being the coordinate 2, 1, B being the coordinate 6, 3. So we're moving from A to B, and we're asked for the gradient of this line. Gradient is found by the rise unit to the run unit. Now if we were to count that and write the gradient formula, rise upon run, and count those units, we would have seen that the number of rise units from 1 to 3 gave us 2 units, and the number of run units would have been 1, 2, 3, 4. In substituting these quantities into our gradient formula, M would have been the rise units, which would have been 2, and the run units, which would have been 4. In simplifying this, would have been the same as a half. So the gradient for this length of line M is a half, which would have been B, the solution to our question. The item refers to the following arrow diagram, which shows a function f. Which of the following best describes the function? Here we have the x values being 2, 5, 8, and 11. What happened with these values, which are the domain values? It undergoes a function, and the result are the range values, which is 5, 8, 11, and 14. Now, when we look at the domain and range values here, we want to know what happens with 2 that makes it 5, what happens with 5 that makes it 8, what happens with 8 to arrive at 11, and what happens with 11 to arrive at 14. We would have seen that if you take 2 and we add 3 to it, we'll get 5. If we take 5 and we add 3 to it, we'll get 8. If we take 8 and we add 3 to it, we'll get 11, and if you take 11 and we add 3 to it, we'll get 14. Hence, our function should have been, for this question, y is equal to x plus 3. That is, every x value, we add 3 to it to give us our y values. So our solution for this question is A. Here we have a right angle triangle, and they give us the reference of the acute angle theta, this being 12 and this being 13. They're asking us, in the triangle, tan theta is equal to what? Now, we need to know that when we're looking at the right angle triangle, we need to label the sides so that we'll know which side we are substituting into which trigonometrical ratio. In this case, 13 would have been the hypotenuse side, and the hypotenuse side we know is the side pointing away from the right angle triangle, or the 90 degrees pointing to that length, which is the longest side. The side opposite the acute angle given or required is the opposite side. Hence, the remaining side of the triangle would have been the adjacent side of the triangle. Now, if you're looking for tan of that acute angle, we would have known that tan ratio is the opposite upon the adjacent. In substituting those values there, tan theta would have been 5 upon 12. So our solution for this question is 5 upon 12, which is B. P equals to the vector 3, 7, and Q equals to the vector minus 2, 5. The question reads, the vector P minus Q is represented by, so we're looking for vector P minus vector Q. In substituting what is P and Q, this would have given us 3, 7 minus 2, 5. In simplifying this question, 3 minus 2 would have given us a value of 5. 7 minus 5 give us a value of 2. So the vector we're looking for is 5, 2, which would have been C, the solution to this question. The item refers to the following diagram of a triangle PQR, in which L is the midpoint of PR, and vector PQ and vector QP equal A, QR equal B. If we were to represent this triangle, they tell us that we have P, Q, R. The midpoint of PQ, it's L. They tell us that QR is the size is B, and QP, the size is A. They're asking us PL, the vector PL, expressed in terms of A and B is, now PL is half of vector PR. So if we find vector PR, and we could find a half of it, and substituting what we know, when we look at the triangle, by the way, we would have seen by triangular law of vector, PQ plus PR should equal to vector QR. And how do we write the rule? We write the rule for the vectors going in the same direction. By triangular law, the two vectors which are going in the same direction should be summed to equal to the one that is going in the opposite direction. And how do we know that the vector is moving from P to R? The question suggests to us that they want vector PL, hence we can make that deduction to show that the arrow is moving from P to Q. Now, in substituting what we know PQ, vector PQ being A. We don't know what is vector PR, but we know vector QR to be B. So vector PR would have been B minus A. Now, they're not asking us for vector PR, they want vector PL, and we know that PL is half of PR. Therefore, we can make that deduction to show that vector PL is equal to B minus A divided by 2, which is the half of the value. So what is B minus A divided by 2 as? The solution for this question would have been B. A square has the same area as a rectangle with sides of 9 centimeters and 16 centimeters. What is the length of the square? Here we have two shapes making comparison. Rectangle, length 16 centimeters, width 9 centimeters. And they're telling us that the area of this rectangle is equal to the area of a square. Now, this area is equal to this area here. So we can find the area of the rectangle. The area of the rectangle would have been length times breadth. In substituting values of length and breadth there, we would have had the length would have been 16 cm times 9 cm, which would have given us 144 centimeters square. If they're telling us the area of the rectangle is equal to the area of the square, therefore area of square is found by L square, we could say that the area of the square, which would have been the area of the rectangle, which would have equal to L square, we can go on to say that the area of A and A2 would have been the same, therefore 144 centimeters square would have been the square area, where the length of the square would have equal to the square root of the area. Therefore, L would have equal to 12 centimeters. That's the length of the square. So our solution is B. In the figure above, for which point is the x-coordinate positive and the y-coordinate negative? Now, on the Cartesian plane, we would have known that in this quadrant here, x is positive, y is positive. In this quadrant here, we know that x is negative, y is positive. This quadrant here, both the x quantity and the y quantity are negative. In this quadrant here, we know that the x is positive and the y is negative. They're asking us which of the values for point P, P is in this quadrant, Q is in this quadrant, R is in this quadrant, and S is in this quadrant. Which of them, the x coordinate is positive and the y coordinate is negative? We're looking for the value of x, the value of S, showing that x coordinate is positive, y is negative. So our solution for this question is D, which is S. The diagram shows the graph of 3x minus y equal 1 and 5x plus 2y equal 20. Which ordered pair x, y satisfy both of the equation? In this question here, we would have seen by method of intersecting graph, where the graph intersects, that gives us the solution. And these two lines intersect at x equal positive 2, y equals 5. So our solution is where this point on the these two graph lines intersect, give us the solution, and the solution would have been the x value being 2, the y value being 5. Hence our solution for this question is 2, 5, which is C. The equation of the line which passes through the point 0, 2 and has a gradient of 1/3 is, in this question we have a point which is 0, 2, and we have the gradient is equal to 1/3. We are asked to find the equation of the line. The equation of a straight line is in the form y equal mx plus c. Now we're given a gradient, we're given a point. To write the equation of a straight line, we need two things. We need a gradient, which was given, and we need a y-intercept value, which is c, and that is unknown. But we can use the point and the gradient to find the y-intercept value. In substituting into the equation of the straight line, we would have had 2 is equal to 0 times 1 upon 3 plus c, where c is equal to 2. Now using c is equal to 2, our equation of the straight line becomes y is equal to 1/3 x plus 2. So the solution for this question would have been D. If f of x maps x squared plus 1, and we're asked to find what is f of minus 3. What we're doing is taking out the x variable into the function and substitute minus 3. So f of minus 3 would have been minus 3 squared plus 1, and minus 3 squared is the same as minus 3 times minus 3 plus 1. Minus 3 times minus 3 give us a positive, 9 plus 1 give us 10. Therefore, f of minus 3 would have been 10. So the solution is A. Which of the following relations below represents function? Now we have I here, A, B, C. We have 1, 2, 3. A is going to 2, B is going to 2, and C is going to 3. Now right there and then we can see this is a function. By definition, a function is a relation in which one element of the domain maps one and only one element in the range. Hence, A is going to 2, B is going to 2. Doing a straight line, this is a function. When we look at number 2, we see that we have A, B, C, and we have 1, 2, 3. A is going to 1, B is also going to 1 and 2, B and C is going to 3. This is not a function because we have this B variable going to more than one values here. When we look at the third relation diagram, we have A, B, C going to 1, 2, 3. Here we have A going to 2, B going to 1, C going to 3. This is a function which is a one-to-one mapping. So the two of them which are functions are 1 and 3. So our solution is B, 1 and 3. Which of the following relations is represented by the graph shown? When we look at the graph, we would have seen the graph represents a straight line, and this straight line passes through coordinate 0, minus 2, and 4, 0. Now, a couple of things we would have known from this question here, that the gradient of this graph, m, would have been rise upon run. So when we look at the rise unit, we're coming for m, which would have been minus 2, upon the run unit, which would have been 4 units. Therefore, our gradient would have been minus a half. Now, point to note is that when we're looking at the gradient, we need to look when we're moving the rise unit from up or down, and in this case, we're going in a downward spiral. So if you're going downward, this value becomes negative. Now, in some cases, because it's blatant here that we can see it on the x-coordinate, when we're looking graphs, when we're counting the x variable, when we're counting the rise unit coming from the top coming downward, we need to understand that this value, when we're coming downward, is in a negative value. So we need to make that representation. So it's very important we understand why this value here, it's negative 2, not only because it's written here. Now, using the gradient value and the y-intercept value, the y-intercept is that coordinate where y equals 0, and where y equals 0 is at that coordinate 0, 4. Using this value, writing the equation would have been y is equal to minus a half plus 4. Now, when we look at this equation here, taking this value over, we would have had 2y is equal to minus x plus 4, and simplifying this equation. Therefore, if we were to bring everything of this over the equal sign and rewrite 2y plus x minus 4 equal 0. So the solution for this question would have been C, 2y plus x minus 4 equals 0. In the diagram, B is due north of C. C is east of B, and AB equals BC. So if we were to draw this diagram, this is what they're telling us. B, this point B, is due north of A, and C, this point C, is due east of B. and AB is equal to BC. They're asking us what is the bearing of A from C. So we're putting the measurement from C, measuring in a clockwise direction until we meet the line from C to A. So we need this angle. Now how do we find this angle? By the straight line concept, we know from north to south, this gives us 180 degrees. How do we find from south to where this line exists? We would have known if this is 90, these two lines are equal, we have an isosceles triangle, therefore this angle is equal to this angle. Those two angles being equal, if one is 90, this one would have been 45 plus 45, because the sum of angles in a triangle, 45 plus 45 plus 90 gives us 180. Now if this is 45, therefore from west to south, this is west, in this direction, from west to south, that's 90 degrees. If we know piece of the angle is 45, therefore this angle is also 45. Now to find from north coming to this line, from north coming to this line AC in a clockwise direction, we need to add 180 degrees plus 45 degrees give us the bearing of A from C, and this, when we sum it, would have been 225 degrees. Hence the solution for our question would have been D. The triangle ABC above shows the angle of elevation of the top B of a tower BC from A to be 30 degrees. AB is 40 meters. The length of BC is. If we were to represent that diagram, we would have seen that we have A, B, C, and they're telling us this angle is 30 degrees and the length AB, this length is 40 meters. They're asking us to find the length BC, which is unknown. Now to find the length BC, what is given is the angle, the acute angle, the side opposite the acute angle is unknown. We also know that the side opposite the right angle triangle, or where the right angle triangle is pointing to, is the hypotenuse side. So we're given a couple of quantities. What were we given? The hypotenuse side is 40 meters. We were given an angle which is 30 degrees. We want the unknown side, which is the opposite side, is x. Using which trigonometric ratio has opposite and hypotenuse, the sin ratio has opposite upon hypotenuse. So in substituting, we would have had sine 30 degrees is equal to x upon 40. Hence, the solution for our question would have been 40 sine 30 degrees by transposition give us x. So the solution for this question would have been 40 sine 30 degrees, which is D. When rotated through 90 degrees about the origin in a clockwise direction, the image of the point 31 is, if we were to represent that point, we have a point 3, 1, and we're rotating this point in a clockwise direction about the origin 90 degrees. If we were to rotate this line 90 degrees, we would have seen to form that right angle, this angle should be 90. That point is moving through a length of 1 minus 3. So when we rotate this point through 90 degrees in a clockwise direction, this image value would have been 1 minus 3. So our solution for this question is C. The range of values of V when 5 minus V is less than or equal to 2V minus 1 is, now when we are solving questions like this, we bring the unknown variable over the inequality sign, group the other values, so we'd have minus minus v minus 2v is less than and equal to minus 1 minus 5, taking a positive value over the equal sign. Summing the like variables, minus v minus 2v give us minus 3v. It's less than and equal to minus 6. Where simplifying, we have minus v is less than and equal to minus 6 divided by 3, where we have minus v is less than and equal to minus 2. But we want a positive v, not a minus v. So what we're going to do, we're going to multiply throughout by minus 1. Minus 1 by minus v give us a positive v. Minus 1 by negative 2 give us a positive 2. A minus 1 times this sign here makes the sign becomes more than and equal to 2. So the solution for this question would have been v is more than and equal to 2, which would have been D, the solution for this question. The item referred to the following graph of a quadratic function. The values of x at the point where the curve y equals 4x minus x squared intercept the line y equals 0 are. If we were to put that graph, the quadratic graph, and look at it, they're asking us where this function, which is y equals 4x minus x squared, and the line y equals 0 meets are, what would have been those values? Now, the line y equals 0, along this line here, along this x coordinate, or this x plane, y would have been 0. If you were to list coordinates at here, it would have been 0, 0. At this coordinate here, where this curve cuts this line, it would have been 4, 0. Hence, at this line here, y would have equal to 0. So, the values where the line y equals 0 would have been x equals 0 and x equals 4. So, our solution for this question would have been A. Where y equals 0, x would have equal to 0 and x equals 4. The item referred to the diagram below. The relationship that best describes the mapping in the above diagram is, and when we look at the relationship, we are having one of this going to many of this. It's not a one-to-one relationship. A one-to-one relationship is when we have one coming from here going across here. So our solution for this question here is many to one, which is C.